All right, well, today is August the 9th, 2017, and right now at 11:30 p.m., we have a temperature of 70 degrees in the foothills of Los Angeles. The relative humidity is 55%. The dew point is 53 degrees, and the barometer is reading 29.90 inches. And right now we're looking at the southwest water vapor map. We can see a huge thunderstorm system, a supercell forming right here in northern Mexico, right on the border of Arizona. This system is growing to be about the size of Arizona right there. And this system is in the very beginning stages of being targeted. If we look at the visible light map, we can see some activity right here, which looks like a blast pattern. If we look again at the water vapor map, this area here was being targeted, this one area, and then this giant cell right here suddenly popped up. We can see this cell that was hit. And that's what we're seeing here on the visible light map right there. You can see that shock wave, that pressure wave moving out right out here. So this is, and of course we can see the photoshopping there in the visible light mode as well. Okay, here's a shot of the, this is the infrared map, the rainbow map. We can see some of that detail. See a pressure wave shooting out to the west right there. So it'd be very interesting to be down in this area and with some cameras to take a look at actually what's happening, what the skies look like as this system is superheated and blown apart. Otherwise, this will move right into Arizona and maybe into California and dump some rain. All right, let's take a look now at the northeast Pacific water vapor loop. We can see that giant supercell forming right there over northern Mexico. We have an upper level low pressure system right here just northwest of the Hawaiian Islands. And this system is completely isolated with high pressure. They've got high pressure installed all the way around that low pressure system. That will prevent any of this jet stream moisture. And we've got also a low pressure system spinning right up here. And all this moisture wrapping around, none of that's going to get into this low, which is not too far from the Hawaiian Islands. And note what's happening right here. This is the jet stream. It's just stopping. It's just walling up right there. And it has nowhere to go, so it's flowing back to the north up around this low pressure that's moving right into Alaska. And of course, we've got high pressure installed right up here, which is preventing this jet stream moisture from getting into this low right up here, which is spinning right off of California. And there's high pressure installed right through the southwest, which is pushing the monsoonal flow. It's just bulldozing it away, so we're not getting any clouds in Southern California or chemtrails. It's been clear, pretty nice for the last few days. Pardon me. And nice clear days. It's been warm. No chemtrails that I've seen in the last few days. So that trend will probably continue based on what we're seeing right here. It's high pressure. This is installed by a transmitter, and this is just forcing everything out to the east, including all this monsoonal moisture right down here in Mexico. This is all being blockaded from moving into the Southern California area or Arizona. And we do see some partial thunderstorm activity moving into New Mexico there. Take a closer look at that here in a second. All right, here's the infrared loop. You can see the jet stream right here just mushrooming right into this area of high pressure. Not going any further than this area right down in here where all this high pressure is installed. Okay, so we've seen that. Here's the western western U.S. water vapor loop, and we can see that supercell developing, and some of that is getting into New Mexico right over here. So you guys may see a lot of chemtrails over here in this area as this monsoonal moisture is forced back to the east by all this high pressure right in this area right here. And we can see that pressure, this transmitter manipulation right in this area. A lot of evaporation going on there towards the end of that loop. And we can see some outflow right in this area as this high pressure is maintained over the west. None of this moisture here is getting any further south. We can see a southbound flow here, but none of that is getting any further south than right about where the pen is. Now, here's the western Atlantic. We have, let's go to the hurricane center map. This is the Franklin right over here, which is now a hurricane with 85-mile-per-hour winds, moving due west at 13 miles per hour with a central pressure of 988 millibar, Category 1 hurricane. We also have a disturbance up here by the just east of Florida with a 10% chance of hurricane formation, and one out here with a 20% chance. Right here, let's take a look at the western Atlantic water vapor loop. We can see that Franklin is moving right into Mexico right about now. And we can see a blast pattern right here on the northeast side of that storm, that icicle pattern right there. That's indicative of a microwave transmitter superheating that core, and we're seeing that superheated water vapor flowing out from the center. Superheated water vapor expands rapidly, and that's why we have that. We see that icicle pattern all the way around these storms that are being targeted. Now here's the Gulf of Mexico water vapor map, and here's Franklin. We can see that icicle pattern right there. This is the infrared loop, and as I've mentioned many times, these hurricanes, this particular hurricane was allowed to build up into a Category 1. This could have been destroyed very easily and wiped out. That was allowed to build up and move onshore. We'll have to see what the damage is down there in Mexico. Here's the visible light map. We can see some photoshopping. And all day long I've been watching the transmitters target this storm, but of course that's a show. It appears that way, that they're making a valiant effort to stop that storm, when in fact they're hitting it with insufficient power. They could wipe this storm out at any time. And the proof of that is, once again, Hurricane Patricia, which hit the western Mexican coast back in October of 2015. And I have not yet put those videos, I think there's 6 of them in that particular series, into a, I have not grouped them yet on my channel, which I plan to do. I've just been very busy lately. So that will be happening very shortly. Stay tuned for that. In the meantime, I did put up Hurricane Matthew. You should see that. If you've not watched what happened to Hurricane Matthew, and there was another hurricane out in the same vicinity, which was pushed out of the way to make room for Matthew. That's quite an interesting video series. Everybody should see that, because that really features the capabilities of these weather controllers and what they can do. Matthew was allowed to plow right over the top of Haiti, and when it started to move towards Florida, it managed to skirt it right along the coast of Florida up here, and it didn't really do much damage at all. Just some wind and some rain, but nothing catastrophic or even no major damage. All right, so that's on the playlist, Hurricane Matthew, and then of course we're going to get the videos for Hurricane Patricia. Those will be done here pretty soon. All right, here's the this is the Doppler map showing that approaching supercell right near Arizona. We can see that there are Doppler radars, those ground-based microwave radars, the Doppler radars that are chopping up the rain pattern. We can see the signature straight edges right here and there and all through here. So that area, which would normally be getting a lot of rain, is being affected by a transmitter right up here in Arizona. I don't have my list out here in front of me, but there are a couple of transmitters, those Doppler radars that actually have dual function. They can detect severe weather, of course, but then they can use their high-powered microwave energy to chop up and evaporate areas of precipitation. And by the way, those transmitters are all run in part by the Department of Defense. So that's interesting. That tells us a lot. Okay, so that's the report, and we'll just leave it right here. And we'll try to do another video tomorrow. Okay, that's it.